So if we take, for example, the graph that's given to us here, using the leading coefficient and some understanding about the zeros of polynomial functions, we can come up with some information about that polynomial function. So, for example, in this case, I know that the highest exponent is going to be odd. And the reason I know that is because from the leading coefficient test, if one side is up and one side is down, that means my graph is disco, which means that the highest exponent is odd. So I can establish that using the graph and using my knowledge of the leading coefficient test. I can determine if that leading coefficient is negative or positive from the same thing. If I'm going down on the right and up on the left, then that means that leading coefficient must be negative. And if we think about, like, if we've established that our highest exponent has to be odd, so let's say it was x to the 5th or x to the 7th or x to the 3rd, well, as I go farther and farther to this side, if I plug in positive numbers for x, the only way my graph is going to produce negative outputs is if I have a negative out front, whether that's a -1 or a -2 or -7 or whatever it might be. Likewise, on the other side, if I plug in negative numbers into my function, I eventually need to end up with a positive number. So if I plug in a negative number into an odd highest exponent, I'm going to get a negative value. So that means I need to have this negative coefficient for me to go up. And then the other thing we want to do, looking at this graph, is we want to identify how many zeros does it have. So let me clean up the diagram a little bit. And for that, we need to take a look up here. So if a 0 appears an odd number of times, so if a 0 appears once, or think of it as a factor, so if x minus 5 was a factor 1 time or 3 times or 5 times, then the graph will pass through the x-axis at that location. On the other hand, if a factor appears an even number of times, if a 0 appears an even number of times, like let's say we had x minus or plus 6 squared or to the 4th power, whatever it might be. So something like this. I know it's not exactly 6, but you can stay with me here. So then it's going to bounce off of the x-axis. So if a factor or a 0 appears an even number of times, we're going to see the graph bounce off of that location on the x-axis. If it passes through the x-axis at that location, then we know that it's going to appear an odd number of times. So if I clean up my diagram here, if we want to try to estimate what is the number of zeros, if we want to come up with a number of zeros for this function, I'm going to count this here as 2. It could be 4, but I'll guess that it's 2 because it's bouncing off of the x-axis there. And then I have these other 3 spots where we're passing through. So I'll count this as 1, another 1, and another 1. So together I get a grand total of 5 real zeros. Now, in the next 2 examples, we're kind of working the opposite direction. We're given some information about the graph based on its highest exponent, as well as its leading coefficient, and the number of zeros that it has. So we want to sketch that graph based on those parameters. So in this one, we have a cubic function, so that's telling us that it's going to be x to the 3rd is the highest exponent. And then we have a positive leading coefficient, so in that case it's going to be the opposite of the one that we have up here, so it's going to be up on the right and down on the left. And it has 3 different zeros is what this is applying, 3 unique zeros. So my graph has to be going up on one side and down on the other. So if it's an odd highest exponent, it's got to be disco. And then we just want to cross through the x-axis 3 separate times, so we can just do something like this. So we're just looking for something that satisfies those parameters. So we've got 1, 2, 3 zeros. We're cubic, so we have to be disco, and a positive leading coefficient up on the right, down on the left. For the last one, a quartic function means it's x to the 4th is the highest exponent. We're told that we have a negative leading coefficient, so that means it would be a negative out in front of that. And then we've got 3 critical points, meaning 3 changes of direction. So first of all, if the highest exponent is even, then it's going to be a touchdown graph. But with the negative coefficient out front here, it means it's going to be our Australian rules football touchdown. So that means both sides are eventually going to take off and go down. And then in between, we want to have 3 critical points. We want to have 3 changes of direction. So I'm going to go, there's 1 change, I can do 2 changes, there's a 3rd change, and then I can take off and go down. So this satisfies all the conditions. X to the 4th means it's going to be a touchdown graph. Negative leading coefficient means both sides are going to be going down to negative infinity eventually. And then we've got our 1, 2, 3 changes of direction, those 3 critical points.